Welcome back. In this next series and our final series of videos in this unit, we're going to talk about derivatives of exponential functions. So an exponential function is any function with the base a raised to a variable power. And one thing that we specify is that base a is not allowed to equal 1 and that a must be a positive number greater than 0. What we can state is that the derivative with respect to x of any base a raised to a variable power is the base a raised to a variable power times the natural log of the base. So, for example, if I asked you to find the derivative with respect to x of 2 to the x, that would equal 2 to the x times the natural log of 2. Or the derivative with respect to x of 3.8 to the x. That would equal 3.8 to the x times the natural log of 3.8. Remember, natural log of a number is just another number. More specifically, though, it is an irrational number. The digits go on and on. D dx of the number pi raised to the x, that would be pi to the x times the natural log of pi, pi being an irrational number. And the last piece we'll do here is we'll say the derivative with respect to x of e, Euler's number, raised to the variable power x. And that would equal e to the x times the natural log of e. Now, remember, natural log is base e. And when the base and the argument are the same, that is equal to 1. So multiplying by 1, we do not need that there. Right? So we have two important rules that we can see here on this screen. We have up top, any base, and then down here, for base e, we have kind of a shortcut rule for base e. All right, so now let's talk about the chain rule with exponentials. So using the exponential chain rule, remember the chain rule is the derivative of the outside times the derivative of whatever expression other than x is inside. And so in this case, it'll be inside the exponent. So let's look at this. D dx, taking the derivative with respect to x of some base a raised to a function, we will say g of x. So other than just one variable, we might have 3x or 3x minus 5, 2x cubed minus x squared. Anything can be up here in the exponent other than x. I could have a sine or a cosine or a logarithm even. So when we have a base raised to an expression, we're still going to apply the rule in the same way. The derivative of the outside is going to be a to the g of x. And of course, because my base is a, I'm going to multiply by natural log of that base. But because I have an expression up here, I will also need to take the derivative of the inside. So that would be g prime of x. That's the derivative of that expression that we had up there. All right. So we have the original exponential times natural log of the base times the derivative of whatever expression is in the exponent. And we can shortcut this rule just a little bit, because if it was e to some function g of x, right? Well, that's going to be e to the g of x. And then we would say times the natural log of e, which of course we know is 1, so we do not need that there, times the derivative g prime of x. So let's look at an example of each of these in kind of a basic situation, and then we will move ahead with some more difficult derivatives using exponentials. So if I asked you to find the derivative with respect to x of 2 to the 3x squared minus 5x, well, that would be 2 to the 3x squared minus 5x. Because my base is 2, I will then say times the natural log of 2. And then I need to multiply by the derivative of what we have in the exponent. And using our power rule, we would get 6x minus 5. So I have here times 6x minus 5. That would be the derivative of that expression. Let's look at one more. So we'll say the derivative with respect to x of 2.9 to the 5 cosine of x. Well, that would be 2.9 to the 5 times cosine of x power. Then we would say times natural log of the base, so the times natural log of 2.9. And then times the derivative of 5 cosine x. The derivative of cosine is negative sine, so I'll get negative 5 sine x. And that's as far as we can go with this one. Now, of course, if the base is e, we don't end up with this natural log of the base in there. So let's just look at one of those examples. Derivative with respect to x of, say, e to the, we'll change that and say 5x squared plus 3x minus 1. So that would be e to the 5x squared plus 3x minus 1 times the derivative of the exponent, which would just be 10x plus 3. And that's my answer there. So I didn't need to write times natural log of e because natural log of e is 1. When the base and the argument match, that logarithm is going to be equal to 1. So that's our basic rule. So now we're going to do a couple more videos where we look at applying this maybe in conjunction with more of the chain rule, some product and quotient rules as well, and maybe mixing some logarithms in there and trig functions more so.